हेलो फ्रेंड्स, वेलकम टू ऑनलाइन गुरु प्लेटफॉर्म पे आपका सहर्ष स्वागत है। टुडेज आवर टॉपिक ऑफ डिस्कशन इज कार्डियक एक्शन पोटेंशियल। फर्स्ट ऑफ ऑल वी आर गोइंग टू डिस्कस व्हाट इज impulse transmission or impulse conduction. Impulse conduction is the conduction of the impulses within the same neuron. See here, there is a conduction of impulses within the same neuron. The neuron is not different. Within the same neuron, when the electrical impulses are going to travel, it is called as impulse conduction. While impulse transmission is when there is a synapse from one neuron to another neuron, the signal is going to get transmitted. Okay, and this transmission of nerve impulses from one neuron to another neuron is called as impulse transmission. Okay, this is the basic understanding. You have to take a note of it because it is very important when we are going to discuss the most important topic of the nervous system. Okay, then what is impulse transmission or conduction? It is a transfer of electrical signals. Okay, when the stimulus will come, it is going to generate an action potential in a one cell. Okay, the action potential from one neuron is going to conduct in the same neuron and it is again going to transmit to another neuron. This process is called as impulse conduction and impulse transmission. Okay, then we are going to discuss cardiac action potential. This is actually the impulse transmission which is going to take place in our heart cells, that is myocardial cells. Okay, we are going to discuss now what is impulse conduction in heart. It is a travel or the propagation of the electrical impulses from the SA node to the ventricles of the heart. Okay, see the actual movement from the SA node, the signal is going to transmit to the AV node, from AV node to bundle of His, and from bundle of His to Purkinje fibers. From Purkinje fibers, it is going to transmit the electrical impulses towards the rest of the ventricles. And when the electrical impulses will reach the ventricles will get a signal to pump the blood. Okay, to contract so that they can pump the blood or eject the blood from the ventricles, from the aorta towards the body cells. Next point is what is membrane potential. First of all, we are going to discuss what is membrane potential before going for the action potential. It is the electrical potential difference. See what electrical potential difference exists in the cell. कोई भी सेल रहेगा ना, उसके बाहर का जो चार्जेस रहते हैं और उसके अंदर के जो चार्जेस रहते हैं वो टोटली डिफरेंट रहते हैं. मोस्टली सेल के बाहर जो ECF है उसमें पॉजिटिव चार्जेस रहते हैं और सेल के अंदर नेगेटिव चार्जेस रहते हैं. Why it is so? Because in the outermost, that is in the ECF, there is abundance, means extreme concentration of sodium ions. As you know, sodium ions are having a net positive charge on them. Therefore, they are going to give a net positive charge in the ECF. And in the ICF, there is excess of potassium. Potassium is also a positive charge ion. Then why the inside of the cytosol is negatively charged? See here, it is due to the constant efflux of the potassium ions from the leaky channels. Potassium leaky channels are present. Through these potassium leaky channels, the potassium are going to move outwards. Due to this, the negative polarity inside the cell, that is into the cytosol, will increase. Okay, that's why सेल के बाहर जो रहता है ना पॉजिटिव चार्ज ज़्यादा रहता है और सेल के अंदर जो चार्ज रहता है वो नेगेटिव चार्ज रहता है. Then we are going to discuss the action potential. What is action potential? Action means क्रिया और potential means सामर्थ्य. कोई भी क्रिया करने के लिए हमें कुछ सामर्थ्य होने की आवश्यकता होती है. अगर हमें कुछ सामर्थ्य नहीं है तो हम क्रिया भी नहीं कर सकते. Okay, to perform any action, we will require our ability. That ability is called as potential. Okay, to generate an action potential, there should be a particular stimulus which should come from the brain. Okay, the heart cells are going to stimulate it. When they are going to stimulate it, when the action potential is going to generate it, when it will receive a signal in the form of electrical impulses from the medulla oblongata, which is located in the brainstem. The medulla oblongata contains cardio-acceleratory center. Cardio-acceleratory center is going to send electrical signals towards the particular nerves into the cranial nerves, and from the thoracic area it is going to transmit towards the SA node. and in AC node there is a generation of action potential. See here, membrane potential is there. There is ECF contains positive charge and cytosol, that is ICF, contains negative charge. It is called as electrical potential difference. And what is action potential we are going to see now. It is a rapid change in the membrane potential. Means the membrane potential, first of all it was positive outside and negative inside. But due to the rapid change in the membrane potential, we are going to experience the rise as well as fall in the membrane voltages. Okay, membrane potential difference is also called as voltage, which is going to take place across the ECF as well as ICF of the cell. Okay, then we are going to discuss what is action potential. It is the rapid change in the membrane potential. It may be rise or fall in the membrane voltage. Okay, then next point is that we are going, it is why it is going to occur. It is due to influx and efflux. Influx means the ions are going to move inwards, and efflux means the ions are going to move outwards. Okay, the electrical charges means the charges which are present are going to move inward. It is called as influx, and when the charge is going to move outwards, it is called as efflux. It may be positive or negative charge. This are going to contribute towards the action potential. Okay, see here, when the sodium ions are going to move inside, okay, it is going to cause the increase in positive polarity into the cytosol. But when these potassium ions which are having positive charge are going to move outwards, it is going to increase the negative polarity into the cytosol. See here, it is going to generate negative polarity. Then we are going to discuss the action potential which is going to take place in the heart. It is called as cardiac action potential. It is very important with respect to your examinations. Then what is cardiac action potential? It is a change in the membrane potential. That is also called as a voltage. It is a change in the voltage, in other terms, across the cell membrane. Means outside the cell as well as inside the cell, there is a change in the voltages. This is called as cardiac action potential. Then we are going to discuss the depolarization phase, which is also called as a rising phase. See here, depolarization, which is called as a rising phase. Why it is so? Because there is a rapid rise in the membrane potential. The membrane potential is going to rise. The inside level, that is a cytosol, the ICF, the negative polarity is going to get decreased. Why it is so? Because there is, when the stimulus is going to stimulate, there is generation of action potential, which will cause opening of the sodium channels, and the sodium will move inside the cell. As you know, sodium is having a net positive charge. The sodium will increase the positive polarity and decrease the negative polarity inside the cytosol. Therefore, there is a increase in the membrane potential. Therefore, it is also called as rising phase of the action potential. Depolarization is also called as rising phase. Then in this, what will happen? Due to sodium influx into the cytosol, there is a change in the electrochemical gradient. Okay, which will make the inside of the cell, that is ICF, cytosol, less negative. Means the negative polarity will decrease due to presence of sodium ions, and it is going to increase the positive polarity. This is the first phase in which the action potential is going to get generated. Next phase is the falling phase, or it is also called as repolarization. In this phase, what will happen? There is a decrease in the membrane potential. There is a decrease in the voltage. Why it is so? It is because due to opening of potassium channels. Potassiums are also having net positive charge. When the potassium is going to pump it out from the cytosol towards the outwards in the ECF, what will happen? Due to absence of potassium, inside of the cytosol will become more negative. It will increase negative polarity inside the cytosol. Okay, and when this increase in the negative polarity into the cytosol is going to take place, this phase is called as repolarization. In this phase, what will happen? The cell will move towards the resting membrane potential. We are going to discuss this in the further slides. Okay, this is due to potassium efflux. Okay, this is due to potassium efflux will increase the negative polarity inside the cytosol. Okay, due to as potassium is moving outward, it will going to generate negative polarity into the cytosol. Then we are going to discuss with hyperpolarization. See, repolarization is going to take place due to due to potassium efflux. Okay, the potassium is going to move outwards, which is going to contribute towards the negative polarity. It is going to increase the negative polarity into the cytosol. Okay. Then wide and clear till this point. The next point is hyperpolarization. In this, what will happen when the efflux of potassium is been still continued for a prolonged period of time? It has already established, it has already reached towards its resting membrane potential. That is generally in cardiac cells it is about minus 90 millivolts. But what will happen when there is a prolonged potassium efflux, even after resting membrane potential is been achieved? Then what will happen? The negative polarity inside the cytosol will still further increase, which will cause the hyperpolarization. Hyper means excessive polarization of the cell. Okay, it is called as hyperpolarization. And this hyperpolarization is going to inhibit the action potential. As we have seen in the depolarization, which is the rising phase, there is a increase in the action potential. It is going to initiate the action potential, while hyperpolarization is going to inhibit the action potential. That's why many of the sedatives, tranquilizers and hypnotics are going to act on this particular action, that is hyperpolarization concept. Opening of chloride channels in GABA, which is going to cause more hyperpolarization into the cytosol, and it is going to inhibit the impulse transmission. Okay, that's why the person is going to get drowsiness. See here, what will happen in this hyperpolarization? Already the sodium channels are closed. There is no influx of sodium channels. Therefore, there will be no positive charge coming inside the cytosol. And also there is additionally there is a efflux of potassium outside the cytosol. Therefore, increasing the negative polarity into the cytosol. The cytosol will become negative inside. But this efflux of potassium, the outward movement of potassium is very prolonged. It is very prolonged. Okay. Then what will happen? Due to this prolonged efflux of the potassium, ultimately the negative polarity inside the cytosol is going to get further increase, and when it goes further rather than the achieving the action potential, therefore it is going to contribute towards the hyperpolarization. Next point is threshold potential. What is threshold? It is actually the critical value. It is the value till which the voltage gated sodium channels are not going to get activated. First of all, I am going to tell you basically, when there is any stimulus which is going to come and stimulate your cardiac cell, one cardiac cell is there, it is impulses is going to come. Okay, when the impulse come, there is an opening of mechanically operated sodium channels. Directly voltage gated sodium channels, that is fast opening sodium channels, are not going to get opened, but initially there is opening of mechanically operated sodium channels when the stimulus is going to approach. Due to this opening, it is very for the brief period, for a transient period, the mechanically operated sodium channels are open for a very short period. Due to this opening of mechanical operated sodium channels, the sodium will come inside the cytosol. Okay, and what will happen? There is increase in the positive polarity, there is a decrease in the negative polarity due to influx of sodium ions. And when this actual potential, membrane potential, reach towards a particular value, this value that is of the membrane potential is called as threshold potential. See here, the diagram is there. The resting membrane potential is minus 90 millivolts. Okay, when there is opening of when there is stimulus coming, it is going to open mechanically operated sodium channels. This will increase the membrane polarity till the threshold. This is a threshold. At this point, there is an opening of voltage gated fast sodium channels. Voltage gated fast sodium channels are going to get open, and it is going to cause rapid influx, very fast and rapid influx of sodium channels, sodium ions inside the cytosol, thus increasing the positive polarity inside the cytosol. Okay, this will, what it will do, it will decrease the negative polarity inside the cytosol. Okay, this phase is called as depolarization, and depolarization wave can only initiate, the action potential can be only initiated when there is opening of voltage gated sodium channels, and voltage gated sodium channels can only achieved when the membrane potential will come till the threshold potential. थ्रेशोल्ड पोटेंशियल जब तक एस्टेब्लिश नहीं होगा तब तक मेम्ब्रेन पोटेंशियल भी एक्शन पोटेंशियल इनिशिएट नहीं कर पाएगा. एक्शन पोटेंशियल इनिशिएट होने के लिए हमें थ्रेशोल्ड पोटेंशियल अचीव करना ही होगा. जब तक थ्रेशोल्ड पोटेंशियल अचीव नहीं होगा तब तक वोल्टेज गेटेड सोडियम चैनल्स ओपन नहीं होंगे, रैपिड इन्फ्लक्स ऑफ सोडियम नहीं होगा और एक्शन पोटेंशियल भी इनिशिएट नहीं होगा. देयर विल बी नो डीपोलराइजेशन आल्सो. ओके, then next point is that we are going to discuss the flow or propagation of electrical impulses through the heart cells. First of all, we are going to discuss what is resting membrane potential. Resting membrane potential is the membrane potential at rest when the actual any neuron or the cardiac cell, when there is no any stimulus. Okay, the cardiac cells are in a relaxed phase. This is what is called as resting membrane potential. Generally, resting membrane potential in the cardiac cells is about minus 90 millivolts. Okay, it is more towards the negative polarity. Okay, now we are going to discuss the flow or the propagation of the electrical impulses through the heart cells. See here, the SA node, which is located in the right atrium part of the heart, is going to receive electrical impulses from the heart. Due to the stimulation in the SA node, what will happen? There is a generation of action potential. This action potential is going to travel on towards the AV node, bundle of his Purkinje fibers, and ultimately it is going to towards the ventricles, where it is going to contract the ventricles and eject the blood towards the body tissues. Okay, this is actually how the electrical impulses are going to move. But microscopically we are going to discuss how it is going to take place. See here, when the stimulus from medulla oblongata is going to stimulate one cardiac cell, what will happen? There is a depolarization due to sodium influx. Then there is a plateau phase, which we are going to discuss further, opening of calcium channels. Then there is a efflux of potassium, which is a phase of repolarization. Then what will happen when this cell is going to get depolarized? There is some gap junctions. Through these gap junctions, some of the sodium channels are going to leak through one cell to another cell. One neighboring cell, that is cardiac cell, it is going to leach into the neighboring cardiac cell. Through these gap junctions, actually the ions are going to move, and when these ions are going to move in this cell, it is going to stimulate the mechanical operated or voltage gated sodium channels. As in this cell also, this mechanical operated sodium channels are going to cause increase in the positive polarity, and it will achieve a threshold potential, and there is a action potential generated in this cell also. Similarly, in this cell also there is a generation of action potential. Like in this way, from one cell to another cell, there is a transmission of electrical impulses through these gap junctions. Okay, ions are moving from one cell to second cell, which will cause depolarization in the second cell. This is the action potential which is going to take place from one cell to another cell in the heart. Then see the diagram. Actually the flow of electrical impulses from the sinoatrial node to the AV node, then bundle of his and Purkinje fibers, and to the ventricles. Okay. Then we are going to discuss the main important topic, that is the phases of action potential in the heart cells. There are total 5 phases. We are going to start with the phase 4. Why it is so? We are going to discuss this now. Because phase 4 is called as a resting phase. What is a resting phase? When there is no stimulus, the heart cells are in a relaxed phase. Okay, heart cells relax हो चुके हैं. इसमें कोई भी इलेक्ट्रिकल स्टिमुलस आया नहीं है. Heart cells are in a relaxed mode. Okay, this is called as resting phase. In this, the resting membrane potential means the membrane potential is nearly about minus 90 millivolt. Why it is so? I have already told you, due to constant leakage of potassium outward from the cytosol. From cytosol, the potassium are always leaking out. into the ECF. That's why inside of the cell is more negative. Okay, and at this point in the resting phase, you have to take a note of it that the potassium as well as calcium channels are closed, they are not at all open. Then we are going to discuss the next phase is called as phase 0, that is depolarization, also called as rising phase. In this, the pacemaker or the electrical impulses which is coming from the medulla oblongata or the cardioaccelerory center towards the SA node is going to generate an action potential in our SA node. From the SA node, it is going to travel towards the rest of the heart, towards the ventricles, and what will happen? There is due to this electrical impulses, first of all there is opening of mechanically operated sodium channels. Further, when the threshold potential is achieved, there is opening of voltage gated sodium channels, and there is a rapid influx of sodium channels. See here, there is a opening of mechanical sodium channels and influx of sodium. When this influx of sodium will increase the positive polarity and the membrane polarity will reach the threshold value or threshold potential, it will open the voltage gated fast sodium channels. And when voltage gated fast sodium channels, these channels are very sensitive to the change in the electrical membrane potential, means voltage. जब voltage जब change हो जाएगा ना membrane cell membrane में, तब ये सोडियम चैनल्स ओपन हो जाएंगे, इसलिए उसको कहते हैं voltage gated fast sodium channels. Then what will happen? There is an influx of the sodium very rapidly, and huge surge of sodium will come inside the cytosol. And at this phase, what will happen? The membrane potential will rise above 0 millivolts for a transient period, for a very brief period, very short period. Okay, at this point there is opening of L type of voltage gated calcium channels. Okay, this will only open when the membrane polarity will increase more than minus 40 millivolts. Okay, means it will go towards more positive side along its concentration gradients. Calcium are located more outside, therefore it is going to move inside as per the diffusion. The next phase is phase 1, that is early repolarization. It is not at all the complete repolarization, but it's an early phase of repolarization. Okay, in this what will happen? Before the opening of the calcium channels, the sodium channels are going to get open for a very short period. Okay, and due to opening of potassium channels, potassiums are mostly inside, therefore as per concentration gradient, it is very natural that the potassium will leak outward outside the cell. Then what will happen? Further it will increase the negative polarity inside the cytosol, and what will happen? The graph, which the membrane potential which has been already increased, okay, it is again going to get decreased for some time, okay, for only some time. And we are going to discuss till it reaches to 0 millivolts, okay, till it reaches to 0 millivolts. Then we are going to discuss the phase 2, that is the plateau phase. Plateau phase means there is a straight curve. Okay, what happens when there is a repolarization wave, early repolarization wave is going to take place, okay, at 0 millivolts till 0 millivolts, the actual early repolarization wave is going to come. Okay, but when it reaches to minus 40 millivolts, there is an opening of voltage gated calcium channels. This voltage gated calcium channels are what they are going to do, they are going to open, and it is going to cause influx of calcium, but still the positive charge is going inside the cell, that is calcium are moving inside the cell, influx is there of calcium. Still there is a plateau, there is a straight plateau. Why it is so? It is due to calcium influx and पोटेशियम इन्फ्लक्स स्टिल कंटिन्यूड. सी कैल्शियम तो अंदर आ रहा है और पोटेशियम भी बाहर जा रहा है ना, तो इसकी वजह से क्या होगा, जो एक्चुअली फेज, जो इस फेज में एक प्लेटो फॉर्म होगा, इसमें मेम्ब्रेन पोटेंशियल ना ही बढ़ेगा ना ही घटेगा, एक स्ट्रेट स्टेडी स्टेट कॉन्सेंट्रेशन of membrane potential will get here. Okay, this phase is called as plateau phase, where there is influx of calcium as well as efflux of potassium. Calcium is going inside, potassium is moving outwards, therefore there will be a steady state balance in the membrane potential. The voltage will maintain, there is no change in the voltage. Hence it is called as plateau phase. Then next phase is the phase 3, that is repolarization. In this what will happen? In this actually there is a inactivation of calcium channels. The calcium channels are going to get closed, but still at this point the potassium channels are open. The voltage gated potassium channels are open. Then what will happen? The potassium, as per concentration gradient, from inside it will move towards outwards. From cytosol it will move towards the ECF. Then what will happen? Potassium net positive charge is going outward. It is going to increase the negative polarity inside the cytosol. अंदर negativity बढ़ जाएगा क्योंकि positiveness बाहर चला जा रहा है. ठीक है? तो इसमें क्या होगा? The potassium efflux is going to take place as going to increase the negative polarity into the cytosol. Finally, the sodium as well as calcium ions which are present inside the cytosol. पहले हमने देखा प्लेटो फेज में कैल्शियम अंदर आए, डिपोलराइजेशन में सोडियम अंदर आए, पर इस सोडियम और कैल्शियम को बाहर भी जाना पड़ेगा ना, और एज पर कॉन्सेंट्रेशन ग्रेडियंट ये बाहर नहीं जा पाएंगे क्योंकि सोडियम और पोटेशियम की जो मात्रा है, सोडियम और कैल्शियम की जो मात्रा है वो बाहर ज़्यादा है, इसलिए उनको बाहर फेंकने के लिए हमें एनर्जी की जरूरत रहेगी. The active transport should be taken place for transporting sodium as well as calcium from ICF to ECF. Okay, because in ECF they are more concentrated. Therefore, against the concentration gradient, against the electrochemical gradient, we are going to pump sodium as well as calcium ions by using some transporter proteins. These transporter proteins are sodium calcium exchanger, calcium ATPase, or sodium potassium ATPase. These are going to utilize the ATP, that is a source of energy, and it is going to utilize the energy which is obtained from the cleavage or breakdown of ATP to pump the sodium as well as calcium channel from ICF, means from the inside, that is the cytosol, towards the ECF, that is outside the cell. This is what is called as repolarization. Repolarization means again the membrane is going towards the negative polarity due to efflux of potassium. Okay. Then see the diagram. First of all, there is a opening, there is a stimulus which is going to come and open the mechanical operated sodium channels. When this membrane potential will reach till this threshold, there is an opening of voltage gated fast sodium channels. This sodium channels which are very sensitive to change in the voltage are going to get open, and there is a huge surge and rapid influx of sodium ions inside the cytosol. Then what will happen? The membrane potential is going to get increased. At this point, the membrane potential will reach above 20 millivolts. Okay, at this point there is an opening of potassium channels and there is a potassium efflux as per the electrochemical gradient. As potassium are located inside more and outside less, from inside it is going to move outward. Then for a brief period, okay, it is for a very brief period, for a very short period, the potassium efflux is going to take place. Till this point there is no opening of calcium channels. You have to take a note of it that till this point there is no opening of calcium channels. This is only the wave which is going to contribute due to the efflux of potassium channels, the opening of potassium and efflux of potassium ions. Okay. And what will happen at this phase? There is opening of calcium channels and also there is a efflux of potassium. The calcium are going to move in, and potassium is going to move out at this phase. Therefore there is no change outside and inside the cell. There is no change in the voltage. वोल्टेज कभी चेंज नहीं होगा इसमें प्लेटो फेज में. क्यों? क्योंकि कैल्शियम भी अंदर आ रहा है और पोटेशियम भी बाहर जा रहा है, मतलब वो स्टेडी स्टेट बैलेंस इक्विलिब्रियम अचीव हो जाएगा. Okay, then this is called as plateau phase, where there is opening of calcium ions channels as well as the efflux of potassium ions along with calcium efflux. Then at this point we are going to discuss next point is repolarization. Repolarization में क्या होगा? There is a opening of, there is a closure of sodium calcium channels. Calcium channels are going to get closed and there is a potassium efflux. Potassium channels, voltage gated potassium channels are still open. बट द कैल्शियम चैनल हैज बीन क्लोज। फिर क्या होगा, पोटेशियम चैनल ओपन है पर सोडियम पर कैल्शियम चैनल्स क्लोज हो चुके हैं, तो कैल्शियम अंदर नहीं आ पाएगा, सेल के अंदर कैल्शियम नहीं आएगा, पर सेल के बाहर तो पोटेशियम जा रहा है, तो क्या हो जाएगा, इट विल इंक्रीज द negative polarity inside the cytosol. Ultimately what will happen, there is a decrease in the membrane potential and it will achieve the resting membrane potential due to constant influx of potassium ions. Okay, this is what is called as resting membrane potential. पर क्या होता है ना, कभी कभार क्या होता है कि potassium ions after reaching the resting membrane potential, still this potassium channels are open for a brief period, for a short period. Then what will happen? The membrane will get further polarized. The membrane potential will go more towards the negative polarity. This is what is called as hyperpolarization. See here, at this point hyperpolarization is going to take place, and when hyperpolarization occurs, there is inhibition of transmission of electrical signals. The impulses are not going to get transmitted. There is an inhibition of transmission of impulses. Okay, then again it is going, the potassium channel closes and again the membrane potential move towards the resting membrane potential. Then refractory period, we are going to discuss what is refractory period. It is a period of a time during which the cell is not able to repeat an action potential. एक बार तो एक्शन पोटेंशियल जनरेट हो चुका है, उस एक्शन पोटेंशियल में और एक एक्शन पोटेंशियल सेल जनरेट नहीं कर पाएगा, इसे क्या कहते हैं, रिफ्रैक्टरी पीरियड. मींस द सेल it is already in the action potential phase, again it is not going to generate a second action potential. This is what is called as refractory phase or refractory period. It is of two types. First one is absolute refractory period. In this period what will happen, the cell is not going to generate a second action potential. Okay, even if we are going to apply a stimulus, एक बार action potential आ चुका है stimulus की वजह से, again we are going to apply a stimulus in that same cell, but there is no a second action potential before the completion of first action potential. Second action potential is not going to get initiated or generated. This is what is called as absolute refractory period. What is the actual range of absolute refractory period? It is from the opening of sodium channels until the sodium channels begin to reset. Okay, the next point is relative refractory period. In this, it is the range or the interval immediately after the absolute refractory period. It is going to take place very quickly, rapidly after the absolute refractory period. In this, what is going to happen? During this phase or period, a new action potential can be achieved. Okay, इसमें एक पॉइंट याद में रखिए कि इसमें एक्शन पोटेंशियल जनरेट हो सकता है. When there is first action potential, okay, again there is, when we are going to apply some stimulus, there is no second action potential going to get generated in case of absolute refractory period. But in this relative refractory period, when there is one action potential generated, we can again generate a second action potential, but there are some conditions. Okay, these conditions, under certain correct condition or circumstances, we can initiate a second action potential in the relative refractory period. See there, the diagram is there. This phase is called as depolarization. This is called as early repolarization. This is the plateau phase. This is the repolarization. Okay, and this phase is entirely called as absolute refractory period. During this phase, there is no action potential is going to get generated. It is second action potential. There is no second action potential which is going to get generated, because this is the entire phase of first action potential. Okay, but during this phase, it is called as a relatively refractory period. During phase, the second potential, the second action potential can be initiated under certain correct circumstances. Okay, this is what is called as refractory period. Then thank you for the lecture. We are going to discuss the further topics which are related to our cardiovascular system in the next sessions or the lectures. Thank you.